Welcome friends to my YouTube channel. Now on today's lecture I shall going to discuss capillaries connected in series. What happens if number of capillary tubes are connected in series? Then what would be the volume of the liquid flowing out per second through each and every capillary tube? Just draw the diagram. Suppose we consider 3 capillary tubes, okay? This is pressure at the end is this end is P2. At this end it is, okay? This is also P2, this is P3, this is P3, this is P4, okay? Suppose in the figure we consider 3 capillary tubes whose lengths are say L1, L2 and L3, and the radius of the capillary tubes are R1, R2 and R3. Okay, and the pressure difference between the two ends of the first tube is P1 minus P2. The pressure difference between the two ends of the second capillary tube is P2 minus P3, and that of third one is P3 minus P4. Now we all know that in this case volume of the liquid flowing out per second through each tube will be same since there is no accumulation of the liquid, okay? So in this case volume of the liquid flowing out per second through all the capillary tubes are same, okay? Volume of the liquid flowing out per second through all the tubes are same, okay? So suppose we imagine this is to be V. So what happens in case of the first tube? Pi, what is the pressure difference? P1 minus P2, and what is the radius? R1. What is its length? L1. So for the first tube we can write the expression of V this. So again for the second tube we can write pi into P2 minus P3 R2 to the power 4 by A eta L2. Fine. Now for the third tube what we can write? Pi into P3 minus P4 R3 to the power 4 by A eta L3. Okay. Now let us simplify this and see what result comes out. Okay. So if we see from this equation, first equation, we can write P1 minus P2. This is simply A eta L1B by pi R1 to the power 4. Okay. From the second expression, we can easily find out P2 minus P3 A theta L2B by pi R to the power 4. And that from the third expression, we can write this P3 minus P4 A theta L3B by pi R3 to the power 4. Okay. Now what happens if we add these equations? Then P2, P2, P3, P3 cancels, so only remains P1 minus P4. Okay. So this is A theta B by pi L1 by R1 to the power 4 plus L2 by R2 to the power 4 plus L3 by R3 to the power 4. Okay. What is P1 and P4? P1 is the pressure at the first end of the first tube, and P4 is the pressure at the last end of the final end of the last tube. So if we imagine this to be P, that is P1 minus P4 as P, so we can write P is A theta V by pi L1 by R1 to the power 4 L2 by R2 to the power 4 plus L3 by R3 to the power 4. Okay. Now from this we can easily find out the expression of V. And what will be my V from this expression? V will be pi P by A theta. This is L1 by R1 to the power 4, L2 by R2 to the power 4 plus L2 by R3 to the power 4. Okay. So this is the working formula when several capillary tubes are connected in series. That means we have to remember that in this case, volume of the liquid flowing out per second through each and every tube will be same, whether we take 2 tubes in series or 3 or more, no matter. So this is the rate of flow of liquid through the capillaries connected in series. Okay. Simple. Now what happens when the capillaries are connected in parallel? Let us see what happens if capillaries are connected in parallel. Just draw the diagram. So here the capillaries are connected in parallel. So in this case we see the pressure difference between the two ends of the all tubes are same. Pressure difference remains same for all tubes. And suppose we consider the pressure difference to be P. P is the pressure difference between the two ends of every tube. So in this case clearly we see if V is the total volume, then it would be divided into 3 parts. That means here from the figure we can easily write V equals to V1 plus V2 plus V3. Okay. Now what would be the expression of V? That is pi P R1 to the power 4 by A theta L1, where L1 and R1 is the length and radius of the first tube. Since pressure difference is same, we can put P also here, R2 to the power 4 by A theta L2, and this is pi P R3 to the power 4 by A theta L1. So if we take pi P by A theta common, it will be R1 to the power 4 by L1 plus R2 to the power 4 by L2 plus R3 to the power 4 by L2. So this is more simple. Okay. So we see that the expression of rate of flow of liquid is different obviously when the capillaries are connected in series and they are connected in parallel. Okay. So in today's lecture we have discussed it. Okay. So dear guys, in our next class we will going to discuss an important method of determining the viscosity of highly viscous liquid. That is, we will discuss about the rotating viscometer process. Okay. And if you don't like this video, then kindly like it and subscribe my channel for latest videos. Okay. Thank you.